Hello students, I am Hitesh Manglani and today we will discuss about Fourier Transform, Fourier Cosine Transform and Fourier Sine Transform. So let's start. So what is Fourier Transform? So Fourier Transform of function f of x, Fourier Transform of function f of x is given by f of s that is equal to 1 divided by square root 2 pi integration minus infinite to infinite f of x into e raised to minus I s x into dx. So by using this formula we can find out Fourier transform of function f of x. Okay, now what is Fourier cosine transform? Fourier cosine transform. Fourier cosine transform of function f of x is given by square root of 2 divided by pi integration 0 to infinite f of x into cos sx dx. Okay, so using this formula we can find out Fourier cosine transform of function f of x. Now what is Fourier sine transform? Fourier sine transform. So it is given by f s of s that is equal to square root 2 divided by pi integration from 0 to infinite f of x into sine sx dx. So using this formula we can find out Fourier sine transform of function f of x. Now let us discuss examples related to this. So first example, find the Fourier transform of function f of x which is equal to x into e raised to minus x for x greater than 0 and it is 0 for x less than 0. So we know the formula of Fourier transform. So we know that Fourier transform of function f of x is given by f of s that is equals to 1 over square root of 2 pi integration from minus infinite to plus infinite f of x into e raised to minus sx dx. Okay, now here we will break this limit, so this will become 1 over square root 2 pi and limit will be from minus infinite to 0. Okay, minus infinite to 0. Okay, but for this limit value of function is 0 because f of x is 0 for x less than 0. So here f of x will be 0 into e raised to minus I sx dx plus integration 0 to infinite. Now value of function for this limit will be x into e raised to minus x because function is x into e raised to minus x for x greater than 0. So for this limit f of x is x into e raised to minus x into e raised to minus I sx dx. Okay, so here integration of 0 will be 0. So this can be written as f of s is equal to 1 over square root 2 pi integration 0 to infinite x into e raised to minus x common in bracket 1 plus I into s into x dx. Now here using Bernoulli's formula, that is integration u v dx is equal to u v1 minus u dash v2 plus u double dash v3 minus so on. Now here v1 is integration of v and u dash is derivative of u. Same way u double dash is derivative of u dash. Okay, and v1 is integration of v, v2 is integration of v1, v3 is integration of v2. Okay, now here this is algebraic function, so we will consider x as a u and e raised to, it is exponential function, so we will consider it as a v. Okay, So now using this Bernoulli formula, this can be written as 1 over square root 2 pi. Here u is constant, so x will be as it is. Then we will take integration of v. So integration of e raised to x will be e raised to x. So e raised to minus 1 plus I s into x divided by coefficient of x. So it is minus into 1 plus I into s. Okay. Minus, now we will take derivative of u. So we will take derivative of x. So derivative of x is 1. Okay. Now to obtain v2, we will have to take integration of v1. So again we will take integration of this term. So integration of e raised to x is again e raised to x, and it is again divided by the coefficient of x. Okay. So this will become e raised to minus 1 plus is into x. Okay. Whole divided by minus 1 plus is into minus 1 plus is. So it will be 1 plus is whole square. Okay. And limit will be from 0 to infinite. Clear? Now here first of all we will apply the upper limit. So for that purpose we will replace x by infinite, because here upper limit is infinite. So here if we replace x by infinite, so this will become e raised to minus infinite, and same way this will become e raised to minus infinite, and we know that value of e raised to minus infinite is 0. So answer of upper limit will be 0. Now we will apply lower limit. So for that purpose we will replace x by 0. So if we put x equal to 0 in this term, then this term will become 0, and here e raised to 0 is 1, and minus minus will become plus. Okay, because one extra minus will come for lower limit. Okay, so this will be f of s is equal to 1 over square root 2 pi 1 upon 1 plus I into s whole square. Okay, so this can be written as 1 over square root 2 pi into 1 plus is whole square. Okay, so this is Fourier transform of function f of x. Now let us discuss next example, that is find the Fourier cosine transform of the function f of x is equal to e raised to minus x square. So we know that Fourier cosine transform of function f of x is given by fc of e raised to minus x square, that is equal square root 2 by pi integration 0 to infinite e raised to minus x square into cos sx dx. Suppose this is result 1 and this is equals to I. Now we will differentiate both sides with respect to s. Differentiating with respect to s, so this will become di by ds. So that is equals to square root 2 divided by pi. Now here derivative of cos x with respect to s will be minus x into sine sx. Okay, so here minus will be common. This will be integration 0 to infinite e raised to minus x square sine sx into x. So writing x over here. Okay, now multiplying and dividing by 2. So this can be written as 1 upon 2 square root 2 by pi integration 0 to infinite sine sx into minus 2x e raised to minus x square dx. Now here applying integration by parts, so this will be u and this term will be v. So this can be written as 1 divided by 2 into square root 2 by pi. So first of all u will be as it is, so sine sx. Now we will have to take integration of v. So if we take integration of v, so integration of minus 2x into e raised to minus x square will be e raised to minus x square. Okay, and here limit will be from 0 to infinite. Then minus, we will take integration 0 to infinite, and derivative of sine sx will be cos sx, and here derivative of sx with respect to s will be s. Okay, and we will have to take integration of, v, that is e raised to minus x square. dx. Okay, now here first of all we will apply upper limit. So here if we replace x by infinite, so this will become e raised to minus infinite, and value of e raised to minus infinite is 0. So here answer of upper limit will be 0. Now for lower limit we will replace x by 0. So here sine 0 and value of sine 0 is 0. So answer of lower limit will be 0 in this case. This can be written as minus s by 2 square root of 2 by pi integration 0 to infinite e raised to minus x square cos sx dx. Okay, now this is what? Okay, from result 1 we can say that this is I. So this is equal to minus s by 2 into I. Therefore di by ds is equal to minus s by 2 into I. So this can be written as di upon I, that is equal to minus s by 2 into ds. Taking integration, now taking integration both sides. So here integration of 1 upon I will be log I. Okay, and integration of minus s by 2 will be minus s square by 4, because integration of s is s square by 2 plus constant, and suppose that constant is log capital A. Therefore this can be written as log I minus log A, that is equal to minus s square by 4. Okay, now we know that log A minus log B is log A by B. So this can be written as log I by A, that is equal to minus s square by 4. Okay, so this can be written as I by A, that is equal to e raised to minus s square upon 4, because their base is e. Okay, therefore I is equal to A into e raised to minus s square by 4, and suppose this is equation number 2. Now when s is equal to 0, then from first result can say that I is equal to square root 2 by pi integration 0 to infinite e raised to minus x square dx. Now here from the definition of gamma function we know that gamma of n is equal to integration 0 to infinite e raised to minus x square into x raised to 2n minus 1 dx. Now here if we put n equal to 1 by 2 in this result, okay, then we will get gamma 1 by 2 is equal to twice integration 0 to infinite e raised to minus x square into dx. Okay, and we know that gamma of 1 by 2 is root pi. Therefore we can say that integration 0 to infinite e raised to minus x square dx will be square root of pi divided by 2. So value of integration from 0 to infinite e raised to minus x square dx is equal to root pi by 2. So putting this result, what was I? It was I square root 2 by pi integration 0 to infinite e raised to minus x square dx. So this will be square root 2 by pi into root pi by 2. So here root pi cancel, and square root 2 divided by 2. So it will be 1 over root 2. So this is the answer of I. Now from result 2, when we put s equal to 0 in result 2, then we can say that I is equal to A, and that is equal to 1 upon root 2. Okay, hence I is equal to, that is Fourier cosine transform of e raised to minus x square will be 1 over root 2 into e raised to minus s square by 4, because their value of A is 1 over root 2. So this is Fourier cosine transform of function f of x, that is equal to e raised to minus x square. Now let us discuss next example, that is find the Fourier sine transform of function e raised to minus mod x, and hence evaluate integration 0 to infinite x into sine mx divided by 1 plus x square dx. So we know that Fourier sine transform of function f of x is given by f of s as integration, that is equal to square root 2 by pi integration 0 to infinite f of x into sine sx dx. Okay, So here this will be square root 2 by pi integration 0 to infinite, and here function f of x is e raised to minus mod x, but for limit 0 to infinite mod x will be x, because here x is positive. Okay, so f of x will be e raised to minus x sine sx dx. We will use the formula, that is integration e raised to ax into sine bx dx will be e raised to ax divided by a square plus b square into a sine bx minus b cos bx. So here if we compare this, value of a will be minus 1, value of b will be s. Using this formula we will get square root of 2 by pi into e raised to minus x divided by 1 plus s square into minus sine sx minus s cos sx, and limit will be from 0 to infinite. Now here first of all we will apply the upper limit, so we will replace x by infinite, so here this will become e raised to minus infinite, and value of e raised to minus infinite is 0, so answer of upper limit will be 0. Now we will apply the lower limit, so for that purpose we will replace x by 0, so here e raised to 0 will become 1, and value of sine 0 is 0, and value of cos 0 is 1, and here minus minus will become plus, so this will become square root 2 by pi s divided by 1 plus s square. Now here using inversion formula, that is f of x equals to square root 2 by pi integration 0 to infinite fs of s sine sx ds. Okay, now here what is fs of s? This is Fourier sine transform. Okay, so this will become f of x into square root 2 by pi integration 0 to infinite. So what is Fourier sine transform of this function? It is square root 2 by pi into s divided by 1 plus s square into sine sx ds. So this can be written as 2 by pi integration 0 to infinite s upon 1 plus s square sine sx ds. Okay, now here what is f of x? It is e raised to minus x, that is given function e raised to minus x is equal to 2 by pi integration 0 to infinite s upon 1 plus s square sine sx ds. Okay, now here in this question coefficient of x is m, so we will replace s by m in this. So replacing s by m, so this will become e raised to minus m 2 by pi integration 0 to infinite s upon 1 plus s square sine ms ds. Now here just writing this as 2 by pi integration 0 to infinite here in the form of x, so this will become x upon 1 plus x square sine mx dx. Now as we have to find out value of this integration, so this can be written as integration 0 to infinite x sine mx dx whole divided by 1 plus x square, that is equals to pi by 2 into e raised to minus m. So this is the value of this integration. So in today's lecture we have discussed about Fourier transform, Fourier cosine transform and Fourier sine transform. Thank you for watching this lecture.